Okay, so let's start our discussion with our topics for today. So ang topics natin is introduction to radio access network or RAN. And then after that, we'll have a discussion on 5G key technologies. Slowly mag-transition tayo from 5G. And then we'll open up yung ating gateway papunta sa Open RAN. Yan. And after that, we'll have a key learning points. Okay? Okay. So let's start with the introduction to radio access network. So I will show you a picture or a video and then let me know ano ang nakikita niyo sa video. Yan. So type in kung ano yung nakikita niyo sa video. What do you see dito sa video? What is this structure? Sabi ni Dennis, this is an antenna. Mr. Ramilo, it's a tower, cell site, tower, antenna, cell site, BTS, cell tower, antenna. So a lot, no? A lot of terminology. RAN, yeah, and RAN structure. So a lot of ideas, no? And conception kung ano yung nakita natin. So later, pag makikita natin, ano yung mga yan, ano? Ano yung structure na yan. So most of the time, most of the people call it cell sites. No? Kapag nakikita nila yan, they call it cell sites. Okay. But for us in the telecom industry, we call it the radio access network. But later on, the radio access network is composed of a lot of components, which we will break down later. So this is an overview of a mobile network coverage. So ito yung ating sample ng mga signal level. No? So in this map, you can see the map of part of the Philippines, which is particularly concentrated on the National Capital Region. So NCR. Okay, as NCR tayo. And part of Bataan area, you can see, and part of Cavite and Rizal area. So yung nakita niyo yung mga different colors indicate the different technologies na present. So this is captured from an app. We call it the kalimutan ko yung app na to, no? Later on, nakalimutan ko yung app ko. Anong app to? NPerf. Thank you, Sir Benjamin. NPerf. Alam na alam ng mga taga-terahertz to. That's ako nakalimutan ko. No? Yeah, NPerf. So NPerf is an application that gathers information from the willing subscriber to give the information. So kung gusto mo mag-participate sa kanilang application, so you can send your data to their server so they could combine it dun sa kanilang application and then everybody can see it. Okay? So meron naman yung permission, no, from the subscriber. So this is not an indication of the current remember, it's not the pure indication of the current status ng coverage ng kahit sinong operator. It depends sa permission na binigay ng subscriber. So kung yung mga subscribers are not giving the NPerf the permission to send the data, hindi mare-record yung data nyo. No? So nakita nyo rito, there are a lot of areas that are covered by 5G already. Surprisingly, no? And meron tayong 4G plus. Okay, meron tayong 4G and then minimum na yung 3G and meron pa ring mangilan-ilan na 2G, no? So ito yung mga overview, no, ng isang mobile network coverage. Okay? So let me just okay. Okay. So let's see, no, yung nationwide mobile coverage. So paano tayo nagkakaroon ng mobile network coverage? Paano kayo nagkakaroon ng signal sa inyong mga phone? How do you get the signal of 4 bars or 5 bars on your mobile devices? So it's because of the radio access network. Okay. So the radio access network, it is the one that gives us the mobile coverage or signal. So this is strategically placed, no, to provide wireless coverage to users within a specific geographic area. Kaya nga siya tinatawag nating cell site, cellular, no. So yung mga cells na yan is maliliit yung mga coverage. So dahil yung ating mga cell sites ay mga low power transmitters that give us sufficient coverage, hindi ganun kalaki, no, katulad ng isang broadcast station ang coverage ng isang cell site. That's why in the likes of the Philippine archipelago, we built different cell sites, no, sa different areas sa ating mga lugar. Okay, so nagtatayo ang mga operators natin like Smart, Globe, and Dito ng maraming cell site, no, or radio access network sa iba't ibang parte ng Pilipinas para tayo magkaroon ng mobile coverage. So when planning the deployment of RAN, network operators consider various factors. Nakita ko kanina sa question, such as kung paano yung nagtatayo ng 5G or a simple cell site, no. It considers various factors. Kasama na diyan yung population density, no, kung ilan yung tao sa paligid. Topography ng area, yung building density, traffic patterns within the coverage area. So kapag pinagsama-sama mo yung mga factors na yan and then you analyze it, so network operators can determine the optimal location and configuration of RAN components to ensure maximum coverage and capacity. Okay? And we need these thousands of RAN elements to have a seamless coverage and mobility. Kaya minsan kaya hindi lang minsan, no, madalas yung problem natin sa coverage could be solved by building a radio access network or cell site sa paligid. Okay? And you will think, sino kaya ang mga tao na nagtatayo ng isang cell site or nagpaplano ng isang cell site? Do you have any idea sino sa industry ang tumutulong for building cell sites in the Philippines, or probably not only in the Philippines but also in other countries? Merong isang engineer, no, na particular diyan. Sino diyan? Can you type in? Sino yung mga engineers na yan? Yeah, syempre, nandiyan yung civil engineers, no? Sila yung nagkatayo ng mga towers eh. Pero yung pinaka radio access network or yung cell site, yung mga antennas, no? Yan. Okay? So typical, yan ay tinatayo ng isang or ginagawa at dinidesign, no? Dinidesign ng isang RF engineer. Yan. Okay? So RF engineers or radio access network engineers, these are professionals, are experts known within the arena of IT and telecommunication sector. Okay? So they are called radio frequency engineers. So usually these engineers work with gadgets and send or receive radio waves with wireless devices. Kasama na yung mga radios and mobile phones. And all kinds of communication run through radio waves. No? Lahat ng mga communication devices that run through the radio wave or RF frequencies, whether wireless or mobile devices, is guided by RF engineer. Okay? So, syempre, sa pag-build ng cell site, hindi lang kaya ng isang RF engineer yan. Okay? So, marami siyang kasama dyan. Nandiyan yung mga transmission engineers for the wireless transmissions, okay, or fiber optic. Andyan din yung ating mga civil engineers, no, sa pag-build ng towers. Okay? Nandyan din yung ating mga drive test engineers, optimization engineers, but those are yung RF at optimization and drive test are considered, no, yung mga sa RF engineering domain. Okay? So ito yung trabaho ng isang RF engineer. Meron ba dito gusto maging RF engineer? Meron ba dito gusto maging RF engineer? Can I get a thumbs up kung sinong gusto maging RF engineer dito sa Pilipinas? So mayroon ako isang kakilalang RF engineer. Yan, yung nakatayo dyan. Ano? Napakilala ko kasi yung minsan. Okay, so if you want to become an RF engineer, ask this guy. Ano nandiyan nakatayo sa tower na yan. Okay? Alright, so tingnan natin. Ano? So let's discuss now what is a wireless telecommunication system. Okay. So ano yung mga components ng isang wireless telecommunication system? So in a wireless telecommunication system, the network is composed of three main parts. Okay, three main parts. Meron tayong tinatawag na user terminals. Yan. Ano yung user terminals, no? So yung user terminals, these are also known as the user equipment or UE kapag ikaw ay 3G, 4G, or 5G. Pero kapag ang iyong phone ay 2G lang, ang tawag natin dyan is mobile station. Okay? Mobile station. So, tignan niyo yung inyong phone. Kapag ang inyong phone ay mga luma na at walang lumalabas kahit 3G or LTE, there's a possibility na yan ay 2G phone or GSM phone. So, ang tawag niya dyan, we call it the mobile station. Okay? Sa telecom industry, telecom world. But if your phones are capable of 3G or 4G or 5G, we call your user terminal as user equipment. Okay? So after ning session natin, after this session, when you try to borrow the user terminal of your friend, you will say, "Hey, pahiram naman ng iyong user equipment." Yan. Or pahiram naman ng iyong mobile station kasi 2G lang yan. Or if you want to buy a new phone in Green Hills or in SM or in any malls, you just ask the sales lady, "Miss, do you have a user equipment there? Can I test the user equipment?" Yeah. Okay. But don't be too technical kasi baka mahirapan sila. Sasabihin ng sales lady sa'yo, "Oh, bakit? Ano yung user equipment?" Kasi I have attended Sir Richard's webinar and we call it now user equipment. We don't call it now cell phone. I need to be more specific. Okay. All right. Okay. So ito yung tawag natin, So 2G is mobile station and user equipment 3G, 4G, and 5G. Okay. Next. This is connected sa ating mga RAN or radio access network. So ang radio access network looks like this, no? Yan. So nakakita na kayo niyan, mga cell sites, right? Yan. So these are the radio access network, no? Kilala yan sa tawag na cell sites. And in studying wireless telecommunications, it's just merely connecting the dots. So to simplify yung ating principle and to simplify the discussion, it's just a matter of connecting the dots. What do you mean by connecting the dots? Meaning, your user terminal will be connected to the radio access network. So, in what means? No? Paano natin i-connect yung ating telepono sa radio access network? Okay? So, we connect it through what we call the air interface. And the air interface, we use the radio frequency. Okay? So, mamaya pag-usapan natin. Ano yung mga radio frequencies na yan? Okay, na ginagamit sa radio access network. Okay? Okay, so we connect it via air interface. So wireless, no? Wala kang makikitang wire. Yan, sasabi nila, "Sir, saka na natin sabihin yan." So wireless ang connection. Okay? So sa radio access network, marami din niyang klase. Ang ating radio access network could be categorized into 2G, 3G, 4G, at 5G. So, kapag ka ang inyong ang inyong cell site ay 2G lang, no? Or GSM mode lang, ang tawag natin dyan is BS, no? Or base station or base transceiver station, no? Minsan BTS, yan, base transceiver station. Kapag ka 3G naman yan, ang tawag natin sa mga cell sites natin sa telecom industry, we call it the node B. And for 4G, we call it the E-node B, the evolved node B. At ang 5G natin, although maraming pangalan ng 5G later on, makikita nyo. But in this example, we call it the G-node B. Okay? Kasi may makikita kayong iba pang pangalan ng 5G. We call it the G-node B or the next generation node B. Okay? Ayan. So ito yung ating mga description ng radio access network. And then after that, kung nakakonect na ako sa cell site, saan pupunta yung aking tawag? No? Para ma-complete yung aking tawag or download or upload, kung may pinapanood ako sa aking TikTok, kung nanonood ako ng mga YouTube channel, okay? So saan ako kukonect? No? Kinakailangan mo kumonect sa core network. Yan. Okay? So sa core network, this one is responsible, no? For managing the overall operation of the network. Okay? Including yung routing ng traffic, between different networks. So kasi pagpasok mo sa core network, no, you will be routed into different networks. Probably sa isang server, sa isang application server, or sa internet, sa Google, or sa Facebook. But you need to go to the core network itself. Okay? And in this core network, it also provides yung mga services like voice call, yung inyong SMS, messaging, and data services. Nandito rin sa core network yung inyong SIM card profile. So, paalala, malapit na po ang deadline ng ating SIM card registration. So, please register your SIM cards before the end of April. I think April 26, no? So, you need to register your SIM cards, no? Otherwise, maano po yan, ma-forfeit. Ito po ay isang paalala mula sa mga operators dito, no? Ayan, so nag-post na si John Martin. Ay, John, meron akong ano dyan, Okay. So reminder, no? So you need to register your SIM cards. Ayan. It's a law here now in the Philippines. Okay. Para hindi mawala para hindi ma-deactivate yung SIM card. Okay. So you need to connect to the core network. Pero sir, paano kami ko-connect? How can we connect the RAN going to the core network? Right? It's just connecting the dots, right? To simplify our concept para mas madali natin maintindihan. Paano natin i-connect ang radio access network going to the core network? So, marami tayong paraan. Actually, meron tayong 4. We call it the backhaul network. Okay? Or the backhaul. No? So, we can connect our radio access network by 4 means. It could be a microwave, wireless. Okay? So, yung microwave looks like this. Okay? May makikita kayong mga bilog na malalaki. We call it the microwave antennas. Yan. So, gumagamit siya ng mga frequencies from 7 gigahertz up to mga 26 gigahertz. No? It depends sa frequency ma-award sa operator. Okay? So, we call it the microwave. And then, we can also use copper or fiber optic, physical facility. Yan. So, mga copper or fiber optic cable. Yan. Or kapag meron tayong blocking or masyadong malayo yung ating mga radio access network sa isa't isa, we can connect it by the use of satellite backhaul. Okay? So, ang tawag natin dyan sa telecom industry is the VSAT or the very small aperture terminal. Okay? So, pwede na natin siya makonect, no? Yung ating radio access network going to the core network. Okay? So, it's just a matter of connecting the dots. No? From the user terminal, radio access network, going to the core network. So, pabalik din, core network, after you get your data, the core network will give you the data na ni-request mo sa kanya, going to the backhaul, to the air interface, and going back to your user terminals. Okay? Clear po ba ito? Itong ating wireless telecommunications system. So, tatlo lang, tatandaan natin. User terminals, radio access network, and core network. Ngayon, papupuntahan natin yung air interface. Okay, kanina, pinag-usapan natin is this connection is wireless. So, we are using an RF frequency or the radio frequency. No? Yan. Or a spectrum. So, what is a spectrum? Yan. So, kapag tinignan natin yung ating spectrum, we have a wide range spectrum in the entire universe. Okay? So, spectrum is the fundamental asset that provides wireless connectivity. So, napaka-importante nito, particularly sa mga operator. Okay? Because if they don't have this frequency, they could not completely deploy radio access network, because radio access network uses frequency, which is spectrum. Okay? So, it is also an invisible, hindi natin nakikita, invisible electromagnetic wave generated by radio transmitting devices. Pero meron tayong electromagnetic energy na nakikita. Can you tell me ano yung electromagnetic energy na nakikita natin? Can you type in? Lalo na sa mga ECE na nandito. Can you type in? Which electromagnetic energy can be seen by the naked eye? Nakikita natin. Yan, very good, no? Visible light. Ang ilaw pala is a type of electromagnetic energy. It's a combination of electric field and magnetic field, no? So ilaw is a kind of electromagnetic energy. Okay? Ngayon, bumababa lang yung frequency. Kapag sobrang baba ng frequency, okay, hindi natin makita yung ilaw na yon, we call it the infrared. Kaya gumagamit tayo ng mga infrared goggles, no, para makita natin yung mga infrared signatures, especially heat ng body. Kapag sobrang taas naman mula sa visible frequency, we call it the ultraviolet, no? Yan. So hindi na natin nakikita yan mula ultraviolet papuntang X-ray at gamma ray. So meaning, habang tumataas yung frequency natin from the visible light going to X-ray and gamma ray, tumataas din yung ating energy dyan. And then we consider those frequencies as ionizing radiation. So ionizing radiation meaning mataas ang energy dyan and then might cause some health, no, effect sa physical body mo, no. Kaya nga minsan kapag yung X-ray, lalo na, no, kapag kayo ay nasa hospital, it is advised na at least once at most, no, once a year kayo mag-X-ray kasi nga meron merong effect sa katawan. Especially yung mga gamma rays na papunta na yan papunta na yung space, yung cosmic ray. But the good thing is, yung mga frequencies below the visible light, infrared, microwaves, radio waves, these are what we call the non-ionizing radiation. Okay, the non-ionizing. Ano yung sabihin ng non-ionizing? Non-ionizing radiations, these are frequencies that do not have an effect sa ating molecular bond, no? Sa molecular structure ng tao. It only causes heating effect. Sabi rin niya ng ICNIRP. Okay? So, yung mga frequencies na ginagamit natin sa mga cell sites, no, sa mga radios, television, sa inyong mga cellphones are considered as non-ionizing radiation and also monitored and regulated ng ICNIRP. Okay? Kaya huwag kayo mag-iisip ng ganong masama doon sa ating mga frequencies, no? Yan. So, hindi yan nakakasama sa tao. Yan. And then makikita rin niyo mamaya kung gaano kalakas yung power natin, no, na ginagamit yan. Which lessen, no, kung yung heating effect na nararamdaman natin mula diyan. Okay? So spectrum is about the frequency measured in hertz. Yan, hertz. Ibig sabihin nanggaling yan sa isang German physicist, si Heinrich Rudolf Hertz, no? Siya ang unang nag-demonstrate ng presence ng electromagnetic energy na kinonceptualize ni James Clerk Maxwell. So James Clerk Maxwell was a Scottish, I think he's a Scottish physicist, no, who theorized the presence of an electromagnetic energy. So mathematical lang, pinrove niya mathematically that there is an energy that is composed of electric and magnetic field. So kaya niya nagawa yung Maxwell's theorem. Okay? So until such time na dumating si Heinrich Rudolf Hertz, doon lang dinemonstrate ni Heinrich Rudolf Hertz sa kanyang simple experiment yung presence ng electromagnetic energy. Kaya sa kanya na-coin yung pangalang Hertz, no? Yung unit of measurement na Hertz. Okay? Nahirapan si Heinrich Rudolf Hertz dyan. Kaya sabi niya, nung matapos niya yan, it really hurts mag-experiment ng ganito. Yeah. Okay? So, operators acquire a license, no? Lalo na kapag mga operating frequencies ng cellular. So, they need to apply a license of a certain frequencies. Nabanggit din niya ni Nicholas kanina. Okay? So before you use a certain equipment that uses radio frequency, particularly yung mga equipment ng radio, ng cell site, at ikaw ay walang license coming from NTC, hindi mo pwedeng gamitin yan. Because it might be assigned to an existing operator na nagbabayad ng malaki sa government. Ang tawag sa binabayad nila dyan ay Spectrum Users fee. Yan. So they pay an annual fee, no, sa government. Okay? Okay. So pwede kang gumamit ng mga frequencies like Wi-Fi kapag ka ito ay syempre yung Wi-Fi is under the free frequencies eh. Under yan ang tinatawag nating kalimutan ko yung term, no? Pero pag naalala ko mamaya. Okay. Sa medical, no? Sa medical and testing industries. Okay? So licenses are normally 10 to 20 years in duration. So it depends sa sa mako. Yan, ISM band. Industry, scientific and medical. Yan. Thank you, Carlo. Yan. Okay? So yung mga Wi-Fi frequencies. All right? So ito yung spectrum. Okay? So gumagamit tayo ng spectrum. So yung frequencies ng ating mga radio access network is nandito. So mababa yung ating frequency compared sa mga ionizing frequencies. Okay? Ayan. Sir, ano pong ginagamit nating frequency sa Pilipinas? Good question. Inanahan ko na kayo sa questions niyo. Okay, so meron tayong 450 megahertz na ginagamit sa Pilipinas. So currently ginagamit ito last time sa CDMA, and then right now we are using it for LTE. So merong isang operator using it sa LTE, no? So 450 megahertz. And then we have the 700 megahertz. Yan. So one of the golden frequencies na gusto-gusto ng mga operators. You have a sufficient bandwidth and the frequency has an effective application for wide coverage applications. Okay. And then meron tayong 850 megahertz previously used for UMTS or 3G, and then later on naging LTE. And then meron tayong 900 megahertz na ginamit natin sa GSM or 2G, and then naging UMTS, naging 3G, and then later on ginamit natin for LTE. Meron tayong 1800 megahertz started used sa GSM, sa 2G, and then later on migrate natin to LTE. Merong 1900 megahertz, merong 2000 megahertz or 2000 megahertz, and 2100 megahertz. No? So makita niya, pag nasa telecom industry kayo, mostly ang tawagan is 100 megahertz, parang US pronunciation. No? Kaya kapag may kausap kayong RF, most of the time we are saying it like 2100. Frequent yung 2100 megahertz. Okay. So some of the RF engineers here might understand me kung paano siya binabasa yung mga frequencies. Okay, so this is 2100 megahertz. Meron tayong 2300 megahertz, 2500, 3300, 3500. So yung ating different colors, kapag yan ay red, these are frequency division duplex frequencies. No, frequency division duplex, and yung mga blue are considered as TDD, the time division duplex. And of course, what's the difference between frequency division duplex and time division duplex? Okay. Currently, right now, we are using 3.5 in 5G, but in the 6 gigahertz, I'm not sure yet if it is awarded, Carlo. But currently for 5G, we're using 3.5 gigahertz and 700. Okay. Yeah, meron din tayong 26 megahertz. So hindi ko na isama yung 2600, no? Yan, nasa boundary kasi nito 2500. Okay. So going back to discussion, what is the difference between FDD and the TDD? Okay, so FDD and TDD is like this. So if you have user terminals, okay, you have a user terminals, and then if you're operating at the FDD, the frequency division duplex, so meaning you have a separate frequency for the uplink. Okay, so think about the frequency as roads, kalsada. Okay, different roads. Like for example, when I say 900 megahertz, if you know South Luzon Expressway, think about South Luzon Expressway as the 900 megahertz. If I talk about 700 megahertz, think about SCTEX, Subic Clark Expressway or Tarlac Expressway. No, so yung mga frequencies natin, consider nyo yan as mga kalsada or mga highway. Okay, so ito yung frequency natin. Pupunta ka sa North Luzon, gumamit ka ng frequency ng North Luzon Expressway. If you are going back to Laguna, you will use the South Luzon Expressway, a different frequency. Okay? And what is the bandwidth, sir? What is the difference between frequency and bandwidth? Now, you go to the South Luzon. That is the frequency, 900 megahertz. How wide is South Luzon Expressway? That is your bandwidth. Okay, so that's the main difference of frequency and the bandwidth. Okay, so there is a different frequency for the uplink mula telepono papuntang cell site na cellular, no? Teka, hindi nagsama-sama. Okay, so there's a separate frequency from the uplink going to the cell site or the radio access network, and your radio access network is talking to your cell phone via downlink frequency. Merong ibang frequency ginagamit. Like for example, this is the northbound NLEX, this is the southbound NLEX. Okay, so this is NLEX, the frequency. Okay, or the South Luzon Expressway. There is a northbound and there's a southbound. Okay, so separate yung frequency nila. Okay, so that is what we call the FDD, the frequency division duplex. Okay, are you getting my point? Nagets po ba ito? Itong FDD? Okay, so clear. So far maliwanag naman, no? Simple lang yung ating discussion. Okay, yeah, 2-lane road. Yeah, tama si Ray, no? Very good. Next is the TDD. The TDD is the time division duplex. So the time division duplex, ang ibig sabihin niyan, isang frequency lang ginagamit natin, no? One frequency lang ang ginagamit natin. So from the user terminal sa inyong cellphone, gumagamit lang siya ng isang frequency, but not separate, no? But they are using it on a time slot basis. Parang one way. Kung kayo yung mga taga Cavite, when nasa tiyempuhan nyo yung tinitigil kayo ng enforcer, teka lang. And then dadaan na yung mga isang bulto ng mga sasakyan. And then after that, you will stop that part of the highway, and then you will allow other vehicles to pass or use the road, no? We call it the buhos. Yeah. Okay. So buhos. Okay. So that's a typical example that everybody can that can relate. No, TDD. Okay. TDD. Okay. So you are using only one frequency. Okay. Ayan. So ito po yung pagkakaiba na. Yan po yung pagkakaiba ng FDD at TDD mode. So if you are assigned to a certain frequency, makalalaman mo na agad after this webinar, if you're using a 450 megahertz, you are using an FDD mode of transmission, meaning the frequency of the mobile phone and the cellular cell site are using different frequencies, okay, in the uplink and the downlink. Ayan. Okay, so hopefully maliwanag po itong discussion natin sa modes of operation. Okay. So now let's move on sa radio access network. Balik tayo sa radio access network natin. Yan. Balikan natin yung radio access network natin. Okay. So kanina pinag-usapan natin yung radio access network. So radio access network or RAN, yan. This is the one that nearest to the subscriber. Okay? Nearest to the subscriber. You see it all around you. So after this session, if you're not very familiar with the radio access network or cell site, hindi ka pa gaanong aware na merong mga cell site sa paligid mo. After this session, your third eye will open for the radio access network. Okay? You will become aware to your surroundings that I am surrounded by the radio access network. Yan. Magbubukas yung third eye mo. And then every now and then when you go out, and then you will see a tower, radio access network, right? If you go inside the mall, you will see a different antenna there, Wi-Fi, radio access network. Okay, you will open up your third eye in radio access network. Okay, so these locations are distributed. Okay, so kalat yan. Okay, kalat na kalat yan. And then thousands of RAN elements create the seamless coverage and mobility. Okay. So, RAN is all around you. Okay, yan. So, magsisimula ng bumuka yung inyong third eye about telecom. It's all around you, no? It's all around you. So, have you ever stopped to think about how your mobile device is able to connect, no? So, dito sila, no? Nakakumukonect. It's all thanks to radio access network. Okay? You can see it in the roadside, in the provinces, on the mountains, on the beach. When you go to Boracay, especially our foreigner visitors here, if you go here in the Philippines, if you go to Boracay, you will see a lot of cell sites on the hill. Okay, and then you will not worry about the coverage here in the Philippines. We have a very good coverage, especially for 5G, especially in Boracay. Okay, and then makikita mo rin siya sa rooftop. Okay. And then when you are shopping inside the mall, you will see a very small radio access network again. And then you can differentiate after this webinar, you can differentiate, that is a Wi-Fi, no, access point, and that is a radio access network cell site, right? And then sometimes when you go with your loved ones, hey, you see that tower, that is a cell site. That's how you become aware of the radio access network after the webinar. Okay? Okay. Okay, so radio access networks can also be categorized, no, into different generations. So it evolves, no. So we'll start our discussion for the evolution. So it all started, the wireless telecommunication started for 1G. Okay, so in some textbooks you can read more about 0G, but we are not discussing it here. No? We'll start with the 1G. So actually, it's hard to believe, no? But not too long ago, communication on the go was limited to radio and landline telephones. Just imagine, some telephones are installed in the vehicle, and the battery itself is the battery of the car. Just imagine carrying that battery in your backpack or throwing your phone to your enemy. No, it's very heavy. No, unlike the battery right now. No? Okay. So that all changed through the introduction of the 1G. So this is the first generation of mobile communications. So it was in 1980. So the famous technology there was the AMPS, the Advanced Mobile Phone System, the TACS, okay, Total Access Communication System, and the Nordic Mobile Telephony. So this is the foundation of mobile technology. So this is based on analog. And then in 1990, GSM came, okay, second generation of mobile communications. It introduces basic voice, digital signaling, and text messaging. So when this technology came here in the Philippines and then introduces the SMS, the Philippines becomes the text capital of the world. In one day, we can generate 100 million SMS per day. I think it's only for NCR. Okay, so during that time, 100 million SMS correspond to 100 million pesos per day. So because one SMS way back in 1990 was 1 peso. Okay, per text. No, very fortunate yung mga ngayon, mga Gen Z natin, no? Unlimited text na ngayon. Okay. All right. So this is the mobile telephony for everybody. Okay. And then we have the 3G. So it's the one that is most famous is the UMTS. Okay. Okay. So the Universal Mobile Telecommunication System. So this is the foundation of the mobile broadband. So this is where we started to have Mbps throughput. Okay. So this is where we started to connect to the internet. Actually, the 2G has a capability of connecting to the internet. But if you are using 2G right now and then you will watch TikTok, especially here in the Philippines, you will not enjoy watching it or watching YouTube, right? It's very slow. Okay. 3G could survive. Could be, yeah, it's quite okay. But LTE is better. Okay. So LTE gives us a further enhanced mobile broadband. Okay, so when we talk about 4G, we are talking about the technology LTE, okay, the long-term evolution. So don't mix this terminologies, right? Like for example, now GSM is 2G. Okay, Global System for Mobile Communication is 2G. UMTS is 3G. LTE or long-term evolution is 4G. Okay, and NR or the new radio is 5G. Okay, so don't interchange these words with the technology. Okay, so because sometimes people interchange, like for example, they say, the UMTS is 4G. It's wrong, no? It should be LTE, should be 4G. Okay, and so now we are in the era of 5G. Congratulations to everybody. We are in the era of 5G, or the fifth generation mobile communications. Okay, so 5G promises to be even faster, no, and more capable than 4G. So previous tests coming from our operators reveals that we can achieve 1 gigabit, no, per second. And we also witnessed that, no? We witnessed that when we tried to do a speed test in Clark. Not only in Clark, right now, 5G is already well distributed here in Manila, in Metro Cebu and Davao. So maabot tayo ng 1 gigabit per second. Just imagine what you will do in the 1 gigabit per second right now. But in the future, probably, if you're using a form factor of for virtual reality or augmented reality that requires a lot of throughputs, you need that 1 gigabit per second. Okay, but currently right now, if you're just using your mobile phone, I think 10 Mbps or 5 Mbps is enough for you to become happy watching your favorite your favorite stream, right? Or joining here in our webinar. All right. So in 5G later on, we will see that there are diverse opportunities that being offered now in this kind of technology. Okay, so ito yung ating evolution of mobile communications. Next, of course, in different evolution, we have different names, right? We have different names. So, dito maririnig nyo naman yung tinatawag nating, like for example, the 2G, we call it the GE RAN. Okay? GE RAN. Okay? Pero sa terahertz, we call it GRAN. So, parang mas madali nila ma-remember. Okay? Ano nga ba yung 2G? Just imagine, 2G has surprised you when it arrives in the Philippines. When it arrives in the Philippines, 2G shouted, "GRAN!" Okay, so GE RAN. No? GE RAN means GSM Edge Radio Access Network. Okay, so you will not forget this. GRAN. Yeah. Oh, yeah. See, Rinaldo said, "GRAN." Pwede nang mag-text. Okay, so everybody in the Philippines was surprised and was excited to use, especially the SMS. Okay, so this is what the name of the 2G network now. 2G RAN is GE RAN. Okay. G is for the generation. Yan. Having Dennis. Yan. 2G is the second generation. Yeah. Next is the 3G. Yeah. So the 3G is UTRAN. Yeah. The UTRAN. UTRAN means UMTS Terrestrial Radio Access Network. So tawag natin sa 3G is the UTRAN. Okay. For 4G, yeah, a lot of guys likes this is EUTRAN. Okay, so in Filipino, they like it so much to say. No, see, a lot of people are laughing. I don't know why. Okay, all right. So EUTRAN. So EUTRAN means Evolved UMTS Terrestrial Radio Access Network. Yan. So ito ang tawag natin sa 4G, EUTRAN. Okay? So evolved, nagkaroon na tayo ng evolved. And then for 5G, we call it the NG RAN. Okay, so next generation RAN. Okay, NG RAN. So when you hear about NG RAN, we are talking about 5G. Okay? So ito yung mga different names, no, ng radio access network in different generations. Okay, clear ba ito? Ano ba ang natandaan nyo dito? Which one do you remember the most? Is it GRAN? UTRAN, EUTRAN, or NGRAN? Lahat, no? Yan. Very good, no? Very good. Okay, so si Erwin is, yan. May sinasabi si Erwin. Ano? Okay. So, let me just have a system check. So, are you all still awake? Tuloy pa ba natin to or... Okay, all right. Okay, now we'll go to run components. Okay, let's move on sa run components. Okay, run components. Anong composition ng isang radio access network? So, iisa-isahin naman natin in this slide. Okay, so hawak kayo sa inyong mga upuan. Medyo ano to, medyo pa-technical na tayo na, medyo nagka-technical tayo. Okay, all right. So first, there's the tower structure. Okay, first is the architecture first. So the simplified architecture, we have the core network, okay? Core network and the radio access network. This one is the radio access network, and then you have the user equipment here, yung telepono. The radio access network is composed of the BBU, the baseband unit, and the remote radio unit. And then meron tayong core network. So ito yung composition ng radio access network. Okay? Kapag tinignan natin yan physically, okay, physically, when you look at the radio access network physically, sabi ko nga kanina, no, your third eye will be open. So whenever you see a cell site, you will dissect the cell site. Not only stare at the cell site, you will dissect it like a frog, like what you did in your biology class. Okay? You don't see anymore a frog. You will see parts of the frog. Okay? Okay. So first is the structure. Okay? The tower structure. So this is designed to be sturdy and stable. So ito yung tower lang. Tower lang talaga siya. Even in high winds and extreme weather conditions. So ang gamit ng tower structure is to hold our equipment. Okay? To put our antenna above, at least on our head. So para mas malayo yung coverage natin. So dito natin nilalagay. And then after the tower structure, meron tayong panel antenna. Okay? Ang tawag natin dyan is panel antenna or directional antenna. Okay? So ang antenna is the responsible for radiating. Okay? Radiating, transmitting, and receiving radio signals between the mobile devices and RAN components. Okay? So ito yung parang antenna natin sa TV. Magkaiba lang yung yung form factor, yung itsura niya. Pero pag binuksan mo yan, mamaya papakita ko sa inyo. Maraming laman yan, maraming radiating elements sa loob. Okay? So we also have the panel antenna with different frequencies. Okay? So meron tayong 1800, meron tayong 900. Para dun sa mga kasamahan natin na not so familiar with the frequencies 1800 and 900 megahertz, there's an analogy with that. Simple analogy, everyday life, no? Simple analogy. If you are listening to radio, AM and FM radio, okay? Consider the 900 megahertz as the AM radio. Okay, mga nagbabagong balita. Isang bata ang pinainom ng suka. Yeah. So AM radio, okay? And the 1800 megahertz would be the FM radio. Okay? 101.9. Yes, FM. Yeah. Ano ba hindi ko alam, no? Hindi ako nakikinig ng FM, no? So, it's AM and FM. Okay? So, you have a different frequency in your cell site. Okay? So, do you get that analogy? I hope so, no? Yeah, ayan. Kailangan pa bang i-memorize yan? Ayan. Okay. Do you need to memorize that in English? Okay. Yeah, 107.5. So these antennas are connected, no, sa ating mga remote radio unit. Merong radio yan, may equipment yan. This is the one that generating the electromagnetic energy. Okay, diyan nag-generate. May mga oscillators yan, may transmitters, may amplifiers, nandyan yan. Okay? Itong antenna natin, ito yung nagra-reject lang, ito yung nagre-receive. Okay? So, yung ating radio could also be two bands, no? Meron tayong 1800, kung may 1800 ka or may 900 ka, meron ka ring 900. So, kung meron kang AM, meron ka ring FM na radio. Okay? And in some advanced radios, we can combine it in one radio. We call it the dual band radio. And the antenna could also be multi-frequency radio. Okay, but in this example, just to show the separation of the frequency ng ating mga system, I prepared this kind of example para makita nyo na meron palang separate frequency kapag 1800 and then merong separate frequency yung 900. But in current or best applications or actual applications, there are equipment and system that you can combine these frequencies in one equipment. Okay. Okay. So meron tayong jumper cables. Okay. Ito yung nagko-connect from radio access network going to the ating radio, no? So yung radio dapat nakakonect yan ng jumper cable. Copper cable. And then yung ating equipment, yung ating remote radio unit is meron yung fiber optic. Ito yung mga makabago ngayon, no? May fiber optic yan papunta sa ating baseband unit. Okay, meron tayong CPRI, Common Public Radio Interface, fiber optic, okay, and then baseband unit. Yan. Tapos yung baseband unit natin could be enclosed into an outdoor cabinet, or kung meron kang indoor cabinet, yung mga container vans, mamaya makikita nyo ibang klase, no? May mga container vans where you put your power system. Siyempre may power supply yan. There's a power supply, there's a ventilation, a fan, or air condition kapag mga container type, and the transmission. Okay, transmission, yung backhaul natin. Okay, so in this example, I use a transmission like a microwave transmission going to the core network. Okay, ayan. So itong example na to, this is the main composition of an outdoor radio access network. Okay, so typically cell site. Currently, here in the Philippines, we have what we call the distributed RAN. So when we say distributed RAN, the radio and the baseband unit are located sa premises ng cell site, in the premises of the cell site, kasama ng tower. Okay, so later on, you will see that there are different types of RAN. The distributed RAN, the centralized RAN, the vRAN, and the open RAN. Okay, pag-iiba-ibahin natin yung mamaya. Okay? Okay na ba tayo dito sa RAN components? So na madadissect nyo na ba kapag kayo ay nakakita ng isang cell site? Most of the time, you will not see the baseband, no? Because there's a fence. Merong fence yung mga cell sites. And most of the time, you will see only the antennas, the microwave antenna, and the radio. The baseband unit, most of the time, these are located below the tower. So you cannot see this. Unless you befriend the security guard. It allows you to check the equipment, no? If you're that's too strong, no, to that kind of negotiation. Okay. Okay. So ito na yung ating RAN components. But sometimes yung mga cell sites natin, no, have different forms, no? Kaya sabi ko sa inyo, kapag nakakita kayo ng cell site, makikita niyo na yung iba't ibang, you will identify, no, what type of cell site is this. But most of the time, the cell sites are almost same. Okay, nagkakaiba lang sila sa kanilang structure, no, sa kanilang tower structure. Okay, so let me show you some examples of the tower structures, different tower structures. So this is what we call the four-legged self-support tower. So this is also a cell site or radio access network, but it is using self-support tower, a four-legged, apat yung paa. Okay, so this type of tower most of the time requires heavy load. Marami kang kinakabit. Okay, kaya ang design ng civil engineer dyan should be sturdy and strong. And sometimes, most of the time, the height goes from 45 meters, 60 meters, up to 90 meters. And then kapag nakita niya, ang daming laman niya, ang daming microwave antennas, there's a lot of antennas, directional antennas, and there's a lot of radios, no, inside. So this is what we call the self-support tower. We are only talking about towers, yung physical structure. Okay, but these are type of radio access network also. Meron tayong tinatawag naman na three-legged. Tatlo yung paa. Okay, cell site din yan, no? Pero tower lang yung pinagkaiba niyan. Okay, so kapag sinabi natin mga self-support tower, we also call it the lattice tower. Okay, mga alam na alam yan ng mga civil engineers natin. That's why RF engineers and civil engineers and transmission engineers and site acquisition engineers are very good friends. Okay, so kapag nagsa-survey sila, no? Sila yung nagde-decide niyan. Okay, meron silang plano. So the RF engineer decides how high the antenna, ano yung mga equipment na gagamitin. The transmission engineer will decide what kind of microwave, anong size ng antenna. And the civil engineer will calculate anong tower type ang ibibigay sa atin. Okay, to handle those specifications coming from RF engineers or transmission engineers, no, para kayanin ang load ng tower. Otherwise, babagsak yan kapag sobrang bigat. Okay? Typical height of the three-legged tower is most of the time is 30 to 40 meters. There are 25 and then there are 30 to 40 meters. Up to 50. Yan. Okay? Depends on the tower loading. And we have the guide tower. Okay? Walang girl tower, no? There's no girl tower, but it's guide tower. Okay? The guide tower uses this guide wire. Okay? Mabilis tong i-deploy. Is easy to deploy and most efficient. Mas tipid sa gamit. Makita niyo naman yung gamit niya, ano? Yan. Pero this type of towers are applicable for the end sites. Meaning, very minimum or very minimal ang loading. You only have this antenna, 3 antennas, and then 1 microwave. Or this type of antennas only. You can see, no? Very minimal the loading of this tower. And then you can see these types of towers applicable so for the end sites, no? End sites, no? Yeah, last mile. Yes, correct. Erwin. Okay. So these are what we call the guide tower. And then if there's a limitation on the space or lot space where you will build your towers, civil engineers might propose a monopole tower. Okay, a monopole. So you see a monopole, like this is a simplified, no, term, monopole. So it's just like a Meralco tower. Okay, no guide wires, no lattice elements. Okay, just a simple monopole. Okay, so if this is applicable specifically if you have a limited space. And we also have this the markings and color of the tower. This is specified sa guidelines ng NTC. Okay. Meron tayong mga ang tawag dito, guidelines na sa pagkulay. Most of the time is red and white. Yan. Yan. SWOT is later. Pakikita natin yung SWOT. Okay. Next is the rooftops. Yan. Rooftops. So these cell sites or radio access networks are located on the rooftop. Installed on the rooftop. So sometimes meron tayong mini tower, okay, or meron tayong tripod like this. We have a tripod, and sometimes we only have this pole, no, bracket, no, yan, mga parapet, no, nakasilip lang, no, sa ating mga rooftops. Yan. So these are the rooftop solutions. And then we have what we call the wall mount. Yan, wall mount, nakakabit sa wall, no? You are using the height of the structure, okay? And then there is no space on top of the rooftop, on the top of the building. The only space available is on the side of the building, so you will put a wall mount site. So you will only use a bracket and then install the antenna, okay? So for the installer, this is one of the difficult part, no? Because just imagine how you will install this. So it needs a very skillful installer to do it. Okay. Yeah. And next is the cell site on wheels. You can see this now. There are cell sites that are running on wheels. Yeah. So these are a radio access network that is designed for emergency situations, okay, for capacity enhancements, for coverage enhancements. No? We call it the cow. cell site on wheels. So different operators have different names. Some operators have what they call meow, mobile equipment on wheels. Okay, meow. And some has a rapid deployment system, RDS. But if you have a cell site with wheels, it's cell site on wheels. Okay? So nandiyan yung mga equipment sa loob. Okay, nandito yung container, like for example, yung container vans na yan, nandiyan yung mga equipment natin, yung ating BBU, okay, yung ating power supply, transmission, nandiyan lahat. Okay? And kung kaya ng tower, nilalagay natin diyan yung ating mga remote radio access, remote radio unit. And most of the time, yung ating mga antennas ang nakalabas. Yan. Yan. Ito yung example ng mga COW or cell site on wheels. Yan. Highest tower with mobile radio, may nakita ako, may 30 meters nito sa isang bansang pinagano ko. But the COW is a trailer. The vehicle is a trailer. Okay? And the extension could go up to 30 meters. Yeah, ito yung pinakamataas na nakita ko. And then sa iba naman, meron tayong mga ganito, up to 5 meters. Yan. Yeah, foldable yan. Foldable yung transport niyan. Okay, yan. Si Mac, meron sa nakita 30 meters sa Mariveles. Yan. Basta kaya ng civil. Kaya yan. Kaya ng civil engineers. Kaya yan. Okay. Now, next is the camouflage sites. Yan. Camouflage. These are stealth tower, no, or SWAT. So, tawag dito sa Pilipinas is SWAT. Yan. Sites. It's a monopole. Sometimes monopole. Sometimes they come as a palm tree. Sometimes they come as a water tank. No, it depends. No, it depends on the creativity of the solution. Okay. So some customers, some clients prefer not to disrupt, no, the I forgot the term, no, the ambience, no, nung environment. If they want to see all greens, so you need to follow the request, no. So ganyan yung ginagawa natin. So the only limitation is our creativity in deploying this kind of radio access network. Okay? Yan. All right. Next is in-building solutions. Yeah. So these are the indoor DAS. Okay? So if you go into the mall, pagka nakakita kayo ng ganyan, mga ganyang antennas, so these are the antennas of an in-building solution or the IBS. Okay? Yan. So ito is IBS. So later na mamaya, papakita ko kayo ng iba bang values ng IBS. Okay? Ayan, no? So ito yung nakikita nyo sa antenna, no? So this is the one that you see when you're walking to the mall carrying your shopping bag. Okay? Or eating some corn while inside the mall. So you see these antennas, no? What you do not see is the system itself. Okay? So the system looks like this. Yeah, so this is the typical indoor system. So you have, like, for example, ground floor or second floor. The equipment is most of the time located sa basement. Okay? It's either on the basement or on the rooftop. Okay? It depends on the approval of the administrator or building admin. And then from there, from the equipment room, you will run a cable. You will run a cable and then install all of these passive component or active component like the antennas. Okay? So pagka tinignan niyo yan, ganyan yung equipment. Same equipment that we are using in the outdoor solution. But what has changed is the antenna system. From the outdoor, we are only using one antenna for one sector. But for this one, we are separating the electromagnetic energy into different antenna. That's why we call it the distributed antenna system. So we are using passive components like splitters, couplers going to our antennas. Okay. So just imagine these are sprinklers. No? So you have the power, the water source, and then you will separate those water supply through different antennas. Okay. So you're just splitting the electromagnetic energy and spreading it evenly inside the building so that you can ensure that there is enough coverage and capacity and quality, improve the quality inside the building or establishment. Okay, so that's like this. No? So you have the signal level, and then if there is a directional antenna like that, so you will have proper and good and balanced coverage and capacity inside the building. Okay, ayan. Okay, clear ba to? Is it clear? Now you will. Now your whose third eye has already opened? Can I get a heart? Can I get a heart? Okay, heart. Okay, heart if your third eye is already open. Wow, that's a lot, no? Okay. For 5G, what are the speeds supported? It depends on the system. Like now, for the 5G, I could only see 4x4 MIMO. And if it's 4x4, I haven't seen the testing yet for the indoor system. How much or how fast was the fastest throughput that we can get? But maybe some of our engineers here who has the experience of testing an IBS, can you share what is the throughput that you get in an IBS 5G? So just type it in here. So I believe there is there is a 800 Mbps coming from Ronald Torres. 800 Mbps. Okay, and 900 Mbps. Okay. Good na, no? 900. Okay. Okay, so ito yung ating indoor system. And then you will hear something about small cell or picocell sites. Okay? So meron tayong mga radio access network like this then. No? So picocell, sometimes napagkakamalan yung mga Wi-Fi access point. But these are small cells. Okay? So these are radio access network system that has low power. Most of the time, ang power nito is nasa 50 milliwatts. 50 milliwatts. Just imagine, 20 watt bulb gives very dim light, no? Just imagine the 50 milliwatt. So napakahina nung nung 50 milliwatt. Okay? So these are the small cell or picocell sites. And then in Singtel, they deploy a portable or private cell sites. And the one that we have seen previously, hindi ko lang nasama, si FireCell. FireCell is something like this also. They have this portable and private cell sites. Okay? So si Singtel, si Ericsson, they also have this. So you can deploy your own 5G 5G network just like what FireCell showed us earlier. Okay? So ang concern na lang doon is yung frequency. What frequency you will use. Okay? Ayan. So yun yung mga different types of cell sites na nakikita natin. So this one is a typical example of cell sites. Pero I believe after this webinar, you will be more aware of your surroundings that, hey, I am surrounded by different types of cell site. Okay? Okay? Okay ba tayo nun? Can I get a thumbs up before we go to the next slide? Now we move on sa ating mga equipment. Yan, na nasa cell site. So kanina, we took an overview about dun sa cell site natin. Oh, sorry. Dun sa cell sites natin. Yan. Took. So let's see it closer, no? Yung RRU. Yan. So the RRU looks like this in sa malapitan, no? In closer view. So when you look at RRU, so these are the radio transmitters that communicates with the mobile devices over the airwaves. Okay, most of the time, the RRUs are located near the antenna to save electromagnetic energy. Kasi kapag sobrang haba, when you are using a very long cable, the electromagnetic energy has only dissipated as heat. Sayang yung power. So the coverage will become smaller. That's why RF engineers decided to put the remote radio unit near the antenna, so that you can save a lot of electromagnetic energy. Okay, so kaya makikita niyo laging nasa taas yan. Okay? So this is the typical RRU. So this is responsible for converting yung mga digital signals from baseband processing unit into analog signals that can be transmitted over the airwaves. Okay, so sila yung gumagawa, nag-generate ng electromagnetic energy. Okay. Next, we have the CPRI. Yan. CPRI, the Common Public Radio Interface. So this is the fiber optic that enables high-speed transmission between the RRU and the BBU. Okay, so allowing this RRU and baseband processing unit to communicate with each other. Okay, CPRI, the Common Public Radio Interface. So this is a fiber optic. So currently, the CPRI is proprietary. Ibig sabihin ng proprietary, yung nangyayaring protocol between these two or this interface is being designed by the current vendors. So what will happen in Open RAN, this connection, this interface will become open. Remember the time nung nagka-charge ka dati ng Android using the cable ng Apple, ayaw gumana. Kasi hindi open, di ba? Kasi hindi open. Ayaw mag-charge. Minsan may mga ganong kable, di ba? Hindi siya open. Because the communication or the protocols designed for that one is not meant to talk with this device and this device. So kinakailangan yung ating interface should be open so that it can talk or it can connect the different hardwares and softwares. It can work with different softwares. Okay? So you can mix and match. So nakikita niyo na yung magiging principle ni Open RAN, no? So in Open RAN, in the current setup, this is proprietary. So it's a black box. Meaning the black box, you don't know how the system works, no? Kung meron sila mga protocols na ginagamit, but it's aligned with the 3GPP. But if it's Open RAN, like what the FireCell shown you, nakikita mo talaga ano yung nangyayari sa loob. Okay? And then you can also dissect what are the different events that's happening. So ganun yung magiging principle ng Open RAN. Okay, so meron tayong CPRI. And then we have this baseband radio, no? Yan. So yung baseband radio, yan. Yan, so the BBU, no? Hindi ang BBU, no? BBU. Sometimes kasi yung mga RF, very sweet person, no? They call it BBU, eh. BBU, this is BBU, no? Not BBU. BBU is responsible for processing the baseband signal and it's placed in the equipment room or connected with the RRU via optical fiber. Yan. And sa baseband din, sa BBU, ako yung nadidistract sarili ko ngayon. Sa BBU, in the BBU, this is also where you activate GSM, UMTS, LTE, and some licenses. No? Dito ka nag-activate. No? Pagka gusto mo yung iyong system na mag-work as 2G, or 3G, or 4G, dito ka mag-activate. As long as supported yung mga frequencies mo ng iyong antenna system and radio. Okay? So dito natin ginagawa yan sa baseband unit. Okay? Ayan. Okay. Ayan na yung ating remote, yung ating composition ng radio access network, no? So right now, kanina pinag-usapan natin that the radio access network has a lot, no? Has come a long way before it arrives sa 5G. So paano nangyari yan, no? So in the next slides, I will show you kung ano yung ginagamit namin sa sa terahertz for my students, no, to easily memorize, no, yung network architecture ng isang complete system from, hindi na namin sinasama tong 1G, from 2G up to 5G. Okay, so whenever they are asked during the interview, the technical interview, most of the technical interviews, like for example for the starters or beginners in wireless telecom, most of the interviews sinasama lagi. It's always included the network architecture. So that's one of the dilemmas of the beginners, how they can explain or how they can memorize the network architecture. And also, if you're trying to get more upskill your knowledge up to the Open RAN, of course, you need to understand the architecture so that you can also understand the architecture of Open RAN. Okay, so let me show you the simplified network architecture of this 2G up to 5G systems. Okay, are you ready? This one becomes technical, but I will try my best to simplify it to the best of my ability. So some of the connections I did not include this to make it simple. Okay, but the most important part is for you to identify the most important parts of the network. Okay, so remember, we have three main parts, right, of the radio access network. Okay, remember this. You have the user terminals, you have the radio access network, and the core network. Do you remember this? Can I get a heart before we begin? Can you remember this? The three main parts of the wireless telecommunication system. Okay, so we will map this into a network architecture. Okay, so you can see that this system works at a different generations, but the same principle. Okay, so let's start with the simplified network architecture. Okay, let's start with the 2G. Okay, the 2G. So the 2G, you have the core network. Okay, you have the radio access network, and you have the user terminals. Okay, so in the core network of the 2G, actually this is not included, no. So this is the outside of the network. So you have the voice or the public switch telephone network. You have the mobile switching center. So okay, so this is the one that's handling the switching of your calls from one area to another area, from one location area to another location area. So anong ginagawa nito? Imagine dati when you are calling long distance call. So when you try from Manila going to Cebu, you need to go to an operator. Hey, operator, I want to connect to Cebu. And the operator will pull the plug and then patch you to another interconnection going to Cebu. So that is the switching office. Now it was replaced by the mobile switching center. So digital na to. Tinanggal yung babaeng naghuhugot nung pinalitan ng malalaking cabinet. Okay? So this is a mobile switching center. Okay? Connected to the mobile switching center is the base station controller. Okay? So base station controller or the BSC. The base station controller handles the control to the BTS, the base transceiver station. These are the cell sites na nakikita natin. Ito yung mga cell sites natin. Base transceiver stations. So the radio access network for the 2G is composed of BSC and the BTS. So may controller. Okay? So the BSC is the one that controls all these BTS, and the BTS is the one that gives radio signal to your user terminals, which is the mobile station. Di ba yung telepono natin, ang tawag natin dyan is mobile station kapag ka 2G. Okay? BTS naman kapag ka base transceiver station na nasa 2G. Okay? So this is the 2G network. And then this one is able to give you voice and SMS. Okay? Text messages. Okay? And then later on, nagkaroon tayo ng data capability sa 2G, which is the Edge and the GPRS. Okay, Edge and GPRS. So yung Edge, kapag ka gumagamit kayo ng telepono nyo, you will see the E and the G. Okay, kapag ka G yan, huwag kayong maniwala na G. The G siya, no? Mabagal yan, GPRS, no? Mabagal yung GPRS. So GPRS means General Packet Radio Service, and the Edge is enhanced data rates for GSM evolution. So ang pinakamabilis na kaya ng Edge is 384 kbps. Pero wala nang iba makakatawag nun, no? 384 kbps. Yun ang ano niya, no? Kaya niya. And then, meron tayong bagong nodes na inintroduce for data network or the packet network, which is the SGSN, the Serving GPRS Support Node, and the GGSN, the Gateway GPRS Support Node. So ito yung papalabas na to, ito na yung internet. Okay? So kung ikaw ay magde-data, okay? Ikaw ay magde-data, kukunik ka sa data, itong route mo. Okay? ikaw ay mag-SMS or ikaw ay tatawag, itong route mo. Okay? Ayan. So, meron kang separate route for CS, circuit switch, and then you have a separate route for packet switch. Okay? So, ito yung simplified architecture for a 2G network. Okay? So, you have the mobile station, you have the BTS, you have the base station controller, and then you have the core network. Yeah, ito yung meron kang circuit CS core network, and then you have this packet core network. Okay? And then later on, dumating si 3G, right? When 3G came, ginamit natin yung existing facilities, no, ng ating 2G sa core network side at yung ating data or packet core. What we have added sa 3G, syempre in physical, is the radio network controller. So yung BSC is in-upgrade natin into radio network controller, and then yung ating mga BTS, we upgraded it into Node B para maging 3G capable siya. Okay? And then yung ating mga telepono, you need to buy a new one, sorry. You need to buy a new one. We call it the UE, the user equipment. Okay? And then yung tawag natin sa buong to ng radio access network is the RNS, no? Radio network subsystem. Yan, ito yung nangyari sa 3G. And then after that, LTE came, right? When LTE came, it introduces a new packet core. We call it the EPC, Evolved Packet Core. And then yung Evolved Packet Core, syempre connected din yan sa internet, which is the PGW, the Public Data Network Gateway, and the Serving Gateway. And then meron tayong MME, the Mobility Management Entity. Ang nangyari kay LTE, the controllers was, the functionality of the controller was transferred sa eNode B. Tinanggal na itong mga BSC, RNC. Nilagay na siya dito sa functionality ng eNode B. Okay? Yung mga cell site natin, na tawag natin ay Evolve Node B. At ang telepono natin is kailangan LTE capable, which is the UE. Okay? Ayan. So, ito na yung ating architecture ng 4G. Actually, maraming parts pa yan, no? Pero hindi ko na sinama yung mga HLR, yung SMSC, kapag hahanapin nyo. No? As I mentioned earlier, I simplified it para mas madaling maintindihan natin. Especially for the beginners. Now, if you're going on a deep dive, the architecture is not as simple as this. Okay? It's more complicated than what you're seeing right now. Okay? But for the beginners, we prepare it as a simplified network architecture. Okay, and could get you the job that you'll want inside the operators. Okay. So meron kang MME, all the control, and then your data here is SGW. Okay. And then nung dumating si 5G, especially dito sa Philippines. Okay, because this one is the roadmap for the Philippine market. Okay. So when 5G came here in the Philippines, we cannot easily adapt the standalone mode. The standalone mode for 5G means you are using a separate core network for 5G. Meron kang separate core network for 5G. And you will be using a standalone mode na radio. And then ang problema ron, yung mga terminals, yung mga user equipment natin, is limited pa lang yung mga standalone. Kaya sa Pilipinas, ang inadapt nating mode ng 5G is the non-standalone mode na operation ng 5G. Ano yung non-standalone mode or NSA? The NSA looks like this. It's very simple to implement. Mabilis ding i-implement. Pagdating ng 5G sa Pilipinas, what we did is like this. We reused, talagang tayo, nakita they reused the existing EPC, the core network of 4G radio. Okay, buy new radio. Okay, and then connect it sa ating existing LTE. Okay, connect it sa ating existing LTE. So, nung nagkaroon na tayo ng 5G, okay, so yung ating mga telepono para mag-function sa 5G network natin is anong ginawa natin? Nag-upgrade ba tayo ng SIM card? Did we only upgrade the SIM cards to avail the 5G service of the current of the operators? What did we anong ginawa natin? we we buy we buy new phones, no? From iPhone 12, iPhone 13, iPhone 14. So these are the 5G capable iPhones. The iPhone 11 is not capable for 5G. So you need to buy a new phone. Okay? Yeah. So you need to buy a phone. Okay? Yeah. So some of the operators here deployed what we call the dynamic spectrum sharing. Okay, so especially the low band, the 700 megahertz, they deploy dynamic spectrum sharing, meaning the radio can be used for LTE and 5G, but can allocate resources based on the number of users. If maraming users sa area with LTE, it will give the resources to LTE technology. And then eventually, if dumadami na yung 5G, it eventually will upgrade yung resources towards sa 5G. Yan. Okay? So sino dito ang naka 5G phone na? Can we get a heart if you're using a 5G system right now? So you will see the rich people here in the Philippines already. So here are the rich people in the Philippines, no? Yeah. Okay. No. So these are the rich people in the Philippines that can afford 5G 5G phone. Okay. Okay, so this is the simplified network architecture. Okay, so for most people, it's not easily it cannot be easily absorbed. Okay, but be patient with yourself. No, so the key here is to draw it one by one, just to memorize it. So especially if you have a technical interview going to operators or vendors here in the Philippines. But if you can memorize this and can write in a piece of paper, I think you're ready for the technical interview, especially if you're going for a radio access network job. Okay. All right. Okay. All right. So before we go to 5G, what time is it? Let's just have a time check. I want to introduce the RAN and OSI layer. Yeah, the RAN and OSI layer. Okay. So the radio access network is divided into different layers. So we are going deep na sa ating discussion. But don't worry, we will make it simple pa rin. So each layer is responsible for different aspects of the system. So one common way of conceptualizing these layers is through the OSI, or the Open Systems Interconnection Model, which is the conceptual framework that describes the communications functions of a telecommunications or computing system. So ano yung mga OSI layer? So the OSI layer is the set of concepts that describe the standardized how a computer or telecommunication system communicates. Kung paano nag-uusap, paano gumagana yung computer mo. Yan. So imagine yung mga remote radio unit natin, yung mga baseband unit natin, consider it as a computer. Wala lang monitor. Okay. Wala lang monitor, no? Computer, no? Parang computer din siya. So sa ating mga system, kapag gumamit tayo ng OSI model, okay, pag gumamit tayo ng OSI model, we use the 7 layers. So meron tayong physical layer, may data link layer, network layer, transport layer, session layer, presentation, and application. Okay, so we will not dig deeper into these layers. Doon natin pag-usapan to sa courses, no, ng Open RAN, ng Asia Open RAN. But for the meantime, we have 7 layers. Now, if you map this sa OSI versus the radio access network layer, yung tatlong to ang pwede mong i-map. Network layer, data link layer, at physical layer. Okay? Yan tatlong yan. Ito, nasa ibang part ng network yan. Ito, nasa radio access network. Nasa pagitan niya ng remote radio unit at ng baseband unit. Mamaya pag i-map natin siya. Now, if you want to memorize this, again, after you memorize it from college, you want to memorize this again. There is a mnemonics. Okay? So all people need to need data processing. Yan. All people seem to need data processing. Yan. So this is the mnemonics, no, that being used, I think, all around the world. But here in the Philippines, we have a specialized version. So Filipinos can easily remember these mnemonics. We are using this one. So if you want to learn this, I will tell you. No? Some they use the please do not throw sausage and pizza away, but that is very foreign. No? But in the Philippines, we use the ang pulis sa tulay nadpa. Yan. Okay? So, ganun pagkakabigkas. Okay? Ang pulis sa tulay nadapa. Meaning, the police in the tulay fell down. Okay? Ayan. The police in the tulay fell down. Okay? Ang pulis sa tulay nadapa. Yan. So, if you want to memorize, no? In the Filipino way. Yeah, but if you don't want, you just need all people seem to need data processing. Okay. Okay. So now let's move on sa run in OSI. So these are the different functionalities of the different layers: application, presentation, session, and transport. So these are the examples. No, you have the HTTP in the application, the ASCII, the RPC, the TCP, UDP in the transport. Now in the network layer, you have the IPv4, right? The L3 switch. But in the RAN, there is a corresponding protocol, which is the RRC. Okay? The RRC. Okay? And then there is the RLC, the radio link control, and the medium access control. And in the data link layer, no? Sorry, in the data link layer. So these are the PDCP, the RLC, and the MAC layer. Okay? And the physical, you have the air interface. Okay? So the physical layer, so if you want to dig deeper on this one, so I'll give you an overview. In the physical layer, this is responsible for the reception of the raw data over the physical medium. Kasama dyan yung copper, fiber optic cables, no? yung reception sa antenna. And this layer includes yung mga systems natin, no? Yung mga physical systems natin. Like yung antenna systems natin. And then we have the data link layer. So yung data link layer naman, this is responsible for transmission ng data over the shared physical medium na gumagamit ng mga protocols like Ethernet or Wi-Fi. Okay? And then kasama dito yung remote radio unit which communicates the mobile devices over the airwaves. And baseband unit, no? Minsan nahahati ito sa baseband unit at the radio unit. And then we have the network layer. Yan. Okay, for routing the data between devices on the network using yung mga protocols na to, such as yung IP, connecting to the core network. Now, if you're going back to the equipment, hardware, and then map those protocols, so nandito yan. Okay? So, yung ating BBU, okay, yung ating BBU, o yung ating munang physical layer is nasa RRU, okay? So, you have this RF conversion, analog to digital, and digital to analog. So, nandito yan sa physical layer. Okay? Yung antenna is nothing, no? Kasi inaano niya na ito, niraradiate niya lang naman sa space at nire-receive niya. So, once na-receive natin yung signal, it will now go to this physical layer. And then after processing, it will go sa BBU natin, okay? So, nandito na yung RRC, PDCP, RLC, MAC, and physical. So, kung papunta tayo dito, dadaan siya sa physical layer, okay? Nandiyan yung error correction, coding, modulation, demodulation, and resource element mapper. So, later on, man yan, sa open run natin pag-uusapan yan, no? Ng detail. And then yung MAC layer, andito yung mga channel mapping, packet scheduling, QoS, yung carrier aggregation, dito nangyayari yan. Radio link control, yung segmentation ng mga packets, concatenation, pinagsasama-sama niya yung mga packets. Okay? Duplicate detection, automatic request. Yan. So kapag may error, yan, dito yan sa RLC. And then yung PDCP, Packet Data Convergence Protocol, dito nangyayari yung IP header compression. So yung data packets mo, nilalagyan niya ng header yan para alam yung destination. Okay? Nandiyan din yung ciphering, integrity protection. Okay? And then yung RRC, ginagamit natin yan for broadcast, paging, connection management, mobility functions, and measurement configuration reporting. So ito yung mga ito yung mga different layers na nangyayari sa BBU. Bakit natin kailangan malaman yan? Later on, kapag pinag-usapan natin 5G and then Open RAN, you will see, kung naalala niyo yung presentation ni Nicholas kanina, yung split, yung functional split, paano natin hinahati yung mga protocols na yan, and then we virtualize the network. Okay? When we say virtualize the network, yung functionality ng mga protocols na yan, we will virtualize. We will make it a software and then install it or create it in commercial off-the-shelf servers. Okay? So, ano yung pag sinabing virtualization? Like for example, pag bumili ka ng radyo dati, ng AM radio or FM radio, anong kinakailangan bilhin? Kinakailangan bumili ng radyo. Okay? And then kasama rin yung hardware ng radyo. Yung pahitan, may antenna. Okay? So, that's the radio. Typical radio. Right now, how do you listen to your radio? Ano yung another alternative sa pagkakinig ng radyo? You use your what? Tuning? Ano pa? Internet? Do you use your phone? Minsan? Phone, no? Do you need to buy another radio pa? Na kailangan pa mag-antena? Hindi na, di ba? You will just install an app. Install an app. Okay? And then you can find the frequency there and then you can just listen to the radio. That's what we call the virtualization. Yung physical component dati, yung functionality na yan, we convert it into a software. No, virtualize na natin. Okay, so ganun din nangyari dito. You don't need to buy our RRU physically, or you don't need to buy a packaged BBU from existing vendors. You need to buy a COTS server, a general purpose processor, and then you install the software there. You virtualize the software there. You just configure, kasi mga open yan. So yun yung magiging principle ng Open RAN. Kaya importante maintindihan natin itong mga protocols na to. Kung nasaan nakalagay ng mga hardware yung mga functionalities na yan. Okay? Okay? Ayan. Wala pa yatang AM radio. Baka nabanggit ko lang. Okay. Okay? So ito yung mga split. So, ang nangyari, pag pinag-usapan natin yung split, sa 3GPP, dinefine nila dati. So, meron tayong BBU, right? And then, meron tayong remote unit. Okay? Nung dumating si 3GPP, under Technical Reference 38.801, okay, nag-propose sila ng splitting. Yan. So, ini-split nila yung mga functions. So, we are separating the functionality ng isang radio access network. So, yung ating core network, syempre, parehas lang yan. Yung ating BBU per se was split into two. Na-split natin yan into CU, the centralized unit, and the distributed unit. And then yung RU is the remote unit pa rin. And then dahil na-split si BBU sa dalawa, yung functionality, hindi hinati yung hardware. Yung functionality ng BBU nahati. So, we have the mid-hole. Nagkaroon tayo na tawag na mid-hole. Yan. And then yung back hole is the same pa rin. And then yung front hole is the same pa rin. And, ang ginawa sa 5G is we separate it. Nagkaroon tayo na splitting and then we open. I-open. In-open natin yung hardware. In-open natin yung interface. And then, software-defined yung mga installed software, yung mga radios dyan. Yan. And then mag-introduce tayo ng Intelligent Management System, the RIC, the RAN Intelligent Controller. Yan. So mamaya pag-usapan natin yan. So pinakita to kanina ni Nicholas about the functional split. Okay? So imagine andito yung ating centralized unit, meron tayong distributed unit, at meron tayong remote radio unit. Okay? So yung mga functionality like yung RRC, PDCP, high RLC, low RLC, MAC, and the physical layer, dun natin dinidefine sa mga physical layers na yan. Okay? So, kapag sinabi nating option 1, so ibig sabihin, yung split natin is between the PDCP and the RRC. Kung meron kang CU, ang nasa functionality lang ng CU mo, yung RRC. And yung functionality ng PDCP hanggang physical layer, nasa distributed unit. Okay? Pwedeng ganun, no? So, sa Open RAN, ang ginagamit natin is the option 7. 2x, no? 2.x. Yan. At option 8. At option 2. Yan. So, inahati natin ang system natin dito at dito. Yan. For the sake of simplicity. And syempre yung cost implication sa pag-manufacture ng radio, ng mga hardware. Just imagine kapag ang iyong remote radio unit is marami ang laman, so yung mga RRU mo, ang mamahal nun. Kasi yung mga chipset sa loob, ang dami niyang functionality sa loob. Pero kung gagawin mo siya sa isang box na DU, at yung mga RU mo is connected lang sa DU, so mas makakatipid ka. Okay? And then ma-achieve mo pa rin yung functionality na gusto mo, no? Like yung iba't ibang mga use cases ng 5G. Okay. So, ganitong ginawa. So, meron kang CU, yung centralized unit. Ito yung BBU nating dati, Ito. No? So, hinati natin sa dalawa. Sineparate natin yung user plane at yung control plane. Yung user plane, ito yung data. Yung control plane, nandito yung control and management. Okay? So, nandito yung mga functionalities and protocols. Okay? Sa centralized unit. And then sa distributed unit, nandito sila RLC, MAC, and high physical. And then sa ating remote unit, nandyan yung low physical and then yung RF. Yan. So ganito natin hinahati yung mga aggregation natin. Okay? Ayan. So typical example ng RAN splitting is like this. Yan. So ganito yung ginawa ni Parallel Wireless, no? So meron kang remote unit. Okay, sa remote radio unit mo, nandun yung physical, no? At yung lower physical na protocol. Yan, ito yung 7.2 split na sinasabi natin. And then yung BBU natin, virtualized BBU yan. Ibig sabihin yung server na to, hindi ito yung mga BBU na nabibili natin sa existing vendors, no? You can use a typical commercial off-the-shelf servers. And then you can define here, ito yung mga functionalities ito, yung high physical, MAC, RLC, PDCP, and RRC. So in this case, yung virtualized BBU niya, nandiyan yung DU and CU. Okay? And meron tayong tinatawag na aggregator. Okay? So pagka marami tayong dinideploy, so meron tayong aggregator, and then nandito na yung core network natin. This one is an application of LTE. Okay, so andyan si SGW, si MME, PGW, and then connected sa internet. Okay, so ito yung traffic split 7. And traffic split 8, makikita nyo, pagkakaiba lang ng 7 at ng 8, the definition ng protocol. Tingnan nyo yung protocol. Yung physical layer, nandito na lahat, no? Sa virtualized baseband unit. Ang natira lang sa RRU is yung RF. So this one is most applicable sa mga 2G at 3G dahil hindi complicated yung circuitry ng 2G at 3G. Pero sa LTE and 5G, this is the one that is being recommended. Kasi gumagamit tayo dito ng mga massive MIMO and beamforming techniques. Okay? Ayan. So ito yung ating mga traffic splits. So sabi ko kanina, we are now with the in the era of 5G, right? So it started way back in 2020 during the pandemic. So they launched 5G. Okay. So what is 5G? No? By the way, what is 5G? So when we talk about 5G, i-breakdown natin siya, no, into 2, 5 and the G. So when you say 5G, ganito lang yung definition ng 5G. 5G is the 5th generation, pang-5 generation of mobile communications na gumagamit that uses new radio access called NR or new radio. Yung sabihin ng NR, new radio, no? So ganoon lang kasimple, no? And connected sa isang 5G core network called the 5GCN and focuses on 3 distinctive classes of use cases. Ano yung 3 distinctive classes of use cases? So we have the EMBB, the Enhanced Mobile Broadband, the Machine Type Communications, the Massive Machine Type Communications or the MMTC, and the Ultra Reliable and Low Latency Communications. Yan, yung URLLC. Pero sir, masyadong malalim yata yung ano. So deep yung definitions ay yung mga use cases. How do we simplify? Simplify natin yung definition. When we say enhanced mobile broadband or EMBB, ang ibig sabihin ng EMBB ay high data rates at high traffic volume. Ayun yung pinaka-simplified definition yan. Enhanced mobile broadband. So mas mabilis yung throughput, nakakaabot ka ng 1 gigabit per second at mas mataas yung traffic na nag-generate mo. Up to gigabytes of traffic. Okay? So ayun yung EMBB. Kapag sinabi naman nating MMTC or Massive Machine Type Communications, ang ibig sabihin naman yan, massive machine type. Tinatawag din natin itong Massive IoT or Internet of Things. Massive number of devices, low cost, and low energy consumption. Okay, so mas marami tayo nako-connect. Up to 1 million devices per square kilometer. Ganyang kadami ang kaya i-connect ng isang 5G technology when we are using yung ating 5G core network. And URLLC. Ano yung URLLC? Ultra reliable. Anong ibig sabihin? What do we mean by ultra reliable? Meaning, the reliability goes to 99.999. So, ganun siya ka-reliable. Hindi siya basta-basta nawawala. Kasi marami tayong backup, marami tayong backup, and then marami tayong mga tawag dito, alternatives, Yan, ng mga connections. Yan, mamaya makikita nyo, meron tayong satellite connections, okay? Meron tayong mga communications, yan. So, ibig sabihin din ng low latency communication, very low latency, up to 1 millisecond yung latency. Ano ibig sabihin ng latency? Response ng network. Kapag ka nag-ping ka, magre-respond agad yung network sa'yo. Hindi ka maglalag kapag ka naglalaro ka ng ML. Okay? And very high reliability and availability. Yung ibig sabihin ng ultra reliable and low latency communications. Ngayon, kapag tinignan natin yung simplified network architecture ng isang 5G, ito yung sabi ko kanina, stand-alone deployment. Okay? Stand-alone deployment. Ibig sabihin, if you are using a standalone deployment or option 2, you are using a 5G core network, hindi LTE. Hindi katulad ng pinakita ko kanina, which we initially adopted here sa Pilipinas, na gumamit tayo ng NSA. This is the non-standalone mode. Ibig sabihin, yung core network ng 5G natin is the existing LTE core network. Non-standalone. Pero yung standalone mode, gumamit na tayo dito ng 5G core network. So ito yung holy grail ng gusto natin makuha. Bakit? Kapag ka nag-standalone mode tayo, itong tatlong to, kaya nating ma-achieve. The EMBB, MMTC, and URLLC, and end-to-end network slicing. Mamaya pag-usapan natin, ano yung end-to-end network slicing? Currently ngayon sa NSA, ito muna, EMBB, ang kaya nating ma-achieve. Okay? And partially ito. Yan. Pero end-to-end, ito dapat. Okay? So, meron kang 5G NR, and then yung iyong UE is a standalone UE. Okay? Standalone deployment. So, tingnan natin yung performance target ng 5G. Yan. So, here, you can see an octagon, okay, and an irregular octagon sa loob, and then you can see the different use cases. The EMBB, the URLLC, and the Massive Machine Type Communications. So, ito yung ating target, ng 5G based sa ITU-R reference and 3GPP references. So, simulan natin sa EMBB. Sa EMBB, ang target ng 5G is a whooping 20 gigabit per second peak data rate. 20 gigabit per second. Ang nakukuha pa lang natin software ngayon is 1 to 2 gigabit or meron ako nakita 3 gigabit per second. Wala pa tayo sa 20 gigabit per second. Okay? Dati, ang target lang na to, itong irregular octagon na ito, this is the target of the LTE previously sa IMT Advanced. Okay? Ang target ng LTE dati is 1 gigabit per second. This one. Now, the target of 5G is 20 gigabit per second. Now, if you will read some white papers about 6G, ang target naman doon is 1 terabit per second sa 6G. Sineset nilang target. But it's not yet official, no? Hindi pa yun, hindi pa yun standardized. Dito muna tayo sa standardized sa 5G. So 20 gigabit per second, 100 Mbps whenever needed, 3 times yung spectrum efficiency, and then yung speed. Tingnan nyo, yung speed. 500 kilometers per hour yung mobility. Okay, so when we visited yung isang laboratory ng isang they show isang F1 race car. So sinasabi, bakit may F1 race car ka dito? Pinapatunayan namin na yung mobility ng 5G kayang i-support kahit ganyan kabilis yung sasakyan mo. So up to 500 kilometers per hour. And then yung latency is 1 millisecond. Yan, for some applications, mamaya makita yung mga applications. And yung massive machine type communications, yung massive IoT, up to 1 million devices per square kilometer. Ganyan karami ang kayang i-serve ng ating 5G system. Okay? So 5G will have 20 times the LTE capacity and then 10 times the user experience rate and in milliseconds level air interface delay. Okay? So anong paggagamitan natin, sir? Saan natin gagamitin niya? Kanina may nagtanong, saan gagamitin ng 5G? Para saan ba yan? Pang ano ba yan? Pampabilis lang ba ng ML yan? Or pampaganda ng mga YouTube videos or reels natin? Okay? So, tingnan natin. These are the use case families ng 5G. Yan. So, marami. No? So, hinahati-hati natin yan. So, starting from the enhanced mobile broadband, you will have something like a pyramid. And then you have the URLLC and low latency communications and the massive machine type communications. So, maraming applications. Like the gigabytes in seconds, nakikita natin ngayon, umaabot tayo ng 1 gigabit per second. Okay? 3D video, okay? Ultra high definition screens. Kapag ganyang kalinaw ang iyong mga screen, kapag ka nag-transmit ka sa network, the network must support this kind of technologies. And 5G can support that. You can work and play in the cloud. Yung mga augmented reality, virtual reality, okay? Na mangyayari na yan. Industry automations. Yan. So yung mga robotics sa loob ng mga factory, it can be supported by 5G, specifically 5G private network. Yan. Self-driving cars. Yan. So yung mga V2X, no? Vehicle to everything. Yan. So nakikita niyo na to sa ibang bansa, no? V2X. Self-driving cars powered by 5G. Smart city. Yan. So marami na tayong mga IoT devices that can be connected sa network. Especially yung mga wireless cameras natin, wireless CCTVs natin, na ayaw natin may cable, gusto natin naka-wireless lang. So it could could be supported by 5G. Smart homes natin. Okay? And syempre meron pa rin tayong mga voice. Okay? So pag tinignan yung mga applications ng 5G, napakarami, no? Yan. So this one is coming from Qualcomm. So these are the concepts na pwede natin mapaggamitan. Yan. Okay? So ngayon, kapag naglalaro ka, nag-upload ka, saka 5G ka, wala kang problema sa streaming, no? Mas mabilis. So that is one of the applications lang. Marami pa tayong applications. Immersive experience, yan, katulad itong virtual reality, and augmented reality, yan, connected vehicle na nabanggit ko kanina. Kahit nasa Shinkansen ka sa Japan, no? Nasa bullet train ka, kaya ka suportahan ng 5G, no? Yung ganung speed, no? Kaya pa rin yan. Ito yung mga remote, yung mga automation sa loob ng mga industry. Yung mga kargamento ni Mayor at ni Congressman, ma-monitor na natin sa mga shippings. Okay? At precision agriculture, yan, importante rin yan. Okay? And mga reliable access to remote healthcare. Okay? Yan. It depends, no, kung gagamitin nila yung technology. But probably it could be a private network. No, it will not be open to public. Yeah, it will not be accessible to public. So naka-separate siya kung gagamitin nila yan. So for military purposes. Okay? Okay. Ayan. So, nasa na tayo sa 5G. Pag tinignan natin ang 5G, last year sa mobile economy, unique mobile subscribers up to 5.7 billion. Tinitingnan nila by 2025. Madami yan. Okay? Mobile internet subscription, aabot sa lang 5 billion in 2025 based yan sa gsma.com. SIM card connections will be 8.8 billion. Okay? And punta tayo sa mobile industry. Smartphones, 84% will be 5G enabled. Yeah. So, yung mga wala pang 5G by 2025, kaka 5G na kayo. Good news. Yeah. And operator, revenue and investment worldwide would be 1.1 trillion US dollars. Laki, no? Laki ng ano. And 12 million jobs, no? So, kaya we encourage everybody, no, lalo na yung mga interesado sa technology like 5G, na magsimula na kayo mag-aral ng 5G, especially kapag kami mga ganitong engagements, right? Because there's a lot of opportunity waiting for you. So if you start now, start early, hindi necessary pag-graduate mo pa, no? Ngayon, kahit estudyante ka pa lang, you can start learning 5G, right? Because there's a lot of opportunities right now. Like for example, in this session, right? We are talking about 5G. So as early as today, you can start learning these new technologies, no, for better opportunities in the future. Bakit, sir? Because as you can see, ang Pilipinas, isa sa mga namumulan, no, na may 5G. Look at this. How Philippines is advanced. We have 5G already, right? Live commercial 5G network. That is based on January last year, 2022. Last year pa yan, ano? Last year pa, meron na tayong 5G. Okay? Nakikipagsabayan tayo sa iba't ibang bansa. Okay? So the good thing here is, if you know how 5G works here in the Philippines, the good news is, when you go to Japan, when you go to different parts of the world that are deploying 5G, we have the same 5G. No, like them. Okay? So we still have the edge, no? Kung ano yung ginagamit nating 5G dito, ganun din ang ginagamit nilang 5G. But I'm not encouraging you, of course, to lumabas na. It's your own preference. Okay? But what we are saying, na we are at par, no? Comparable sa 5G deployment sa ibang bansa. Okay? Ayan. Okay. So, tingnan natin ang 5G. Sir, paano ba nakikita kapag 5G na po ang isang system? Okay. Paano ba nakikita, no? So, like for example, meron tayong tower. Ito ulit yung tower natin kanina. Okay? Naalala niyo to? Can you remember this? Ito yung tower natin kanina. Okay? So, mangyari, kapag may 5G, may makikita kayong bagong antena. Okay, so this one is what we call the 5G active antenna unit. Okay, meron tayong bagong antenna and then probably meron tayong bagong baseband unit. Okay, for 5G activation. And then kapag tinignan mo yan sa labas, when you look at the tower using your third eye, you will see a 5G antenna. Most of the time, these are the massive MIMO antennas. Itong maliliit na to. Kasi we are using 3.5 gigahertz, no? Yan. These are the 5G antennas. Okay, can you see this? Nakita niyo ba? Nakikita niyo ba? Yan. Okay, so your third eye is already open. Kung nakikita niyo na to, no? Okay. So these are the 5G implementation samples, no? Dito sa Pilipinas. Sa Pilipinas yung kinuha. Kinuhanan ko lang sa labas nung nagbabike ako. Okay? So let's take a look quickly ano yung mga kailangan natin matutunan about 5G. Okay? So, meron tayong 5G is operating using a MIMO system. No? Massive MIMO. And then MIMO of 8x8 MIMO or 4x4 MIMO. Ano yung sabihin ng MIMO, sir? MIMO means multiple input, multiple output. Okay? Multiple input, multiple output. So, dati, nagka-transmit lang tayo ng isang signal sa isang antena. So ngayon, meron tayong 4 na streams. Ito yung natawag nating MIMO. Okay? Meron tayong 4x4 MIMO, 4 transmit, 4 receive. Meron tayong 4x2 MIMO. Meron tayong 8x8 MIMO. And meron tayong 2x4 MIMO. Okay? So, ito yung types of MIMO. No? Pag sinabi naman nating massive MIMO, gumagamit tayo ng special type of antenna like this. Okay? It's a sample of a Nokia massive MIMO antenna. Marami siyang laman sa loob, no? Ng mga antenna elements. Meron tayong 64 transmit and 64 receive antennas. Pagkatingnan natin sa loob yan, yung massive MIMO natin would look like this. Ang daming elements. Meron tayong 192 antenna elements sa loob. Ganyan ka-complicated ang antenna ng isang massive MIMO antenna. Okay? Ayan. So kapag kapag ganyan ang gamit natin, we can go for a beamforming. No? Nagbi-beamforming tayo. So dati, nakaka-isang beam lang tayo. Pag nagbuga tayo, parang isang flashlight. Ngayon, sa massive MIMO, parang maraming laser. No? Nasa isang ganun. So meron kang massive MIMO. Meron kang beamforming technique na ginagawa. So yung beamforming, you are steering, no? Yung pinaka-beam natin towards your user. Hindi ka nagbubuga basta-basta kung kani-kanina. Hindi parang shotgun yan. Ito parang sniper. Okay? You are targeting your subscriber. So, ayun yung tinatawag nating beamforming. Okay? Ayan. Next is frequency. Ayan. So, sa 5G, we have frequency range 1 and frequency range 2. Okay? Frequency range 1 and frequency range 2. So, when we talk about frequency range 1 and frequency range 2, meron tayong iba't ibang mga frequencies. So, ito yung mga frequency range 1 and frequency range 2. Frequency range 1 is starting from 410 MHz up to 7.125 GHz. Ito yung mga existing frequencies natin actually. Pwede mong i-reuse for 5G. And then we have frequencies in the 24.25 GHz up to 52.6 GHz. Ang tawag natin dito is FR2. Kilala rin ito sa tawag na millimeter wave. Yan. So may narinig yung millimeter wave yun. Okay? Ayan. Ito yung ating FR1 and FR2. Transmission mode. Yan. So ang 5G is pwede rin siyang TDD at FDD. Yan. Ano yung TDD at FDD, sir? Parang narinig ko na yun. Siyempre, ito yung nakita natin kanina, right? FDD and TDD. Ang 5G pwede rin po dyan. Okay? Depende sa frequency gagamitin mo. Di ba? Kung ang frequency mo nandito, FDD. Kung ang frequency mo nandito or other frequencies, TDD. Okay? What else? Ano pa yung mga kailangan ating mga basic na matutunan sa 5G? Architecture. Yan. Non-standalone mode at standalone mode. Yan. So, kanina binanggit natin to, di ba? Ang non-standalone mode is ganito. So, meron kang LTE. Kinonect mo yung ating LTE at G-Node B. Dinagdag mo lang siya. Ang tawag natin dyan is non-standalone mode. Ang standalone mode, meron ka sariling 5G core network. Ganyan kasimple yung standalone mode. Bakit natin prefer ng standalone mode? Dahil ito can support end-to-end network slicing at yung tatlong use cases, EMBB, URLLC, at massive machine type communications. Pero kailangan mo ng core network na 5G. Okay? Ano yung ating mode? Ano pa? Voices. Siyempre, meron tayong voice service sa 5G. Ang tawag natin yan is VoNR. No? Voice over NR. Yan. Meron tayong voice over NR. Yan. Okay? So, meron tayong mga different options sa 5G. And then, ito yung ating mga different voice services. So, kung meron tayong VoLTE, meron tayong VoNR. Yan. So, gagana yan kapag syempre, meron tayong 5G core. Okay? So, huwag kayong mag-alala, hindi mawawala ang voice services. Okay? Nandiyan pa rin ang voice services sa 5G. Uy, location. Ano tong location, sir, ng 5G? Pwede tayong terrestrial at pwede tayong non-terrestrial network. What is the non-terrestrial network, sir? Ang terrestrial network, ito yung mga cell site natin na nakabaon sa lupa. Okay? Nakabaon sa lupa. Okay? So, yung nakabaon, ito yung mga terrestrial network natin, yung mga towers na nandyan sa paligid, yung kanina mga cell site na pinakita ko kanina. Yan. Ito yung terrestrial network. Pero kapag kaya ito ay lumipad, once the network is based on a spaceborne spacecraft, or an aerial platform for radio transmission, we call it the non-terrestrial network. Kasama dyan yung mga drone, okay, na merong 5G capability or LTE capability. Nandyan yung mga HAPS, okay, HAPS or high altitude platform. And then in the future, andyan kasama na sila LEO satellites. Yan, okay? So yung mga G-Node B natin, yung mga radio natin, i-equip natin dun sa 5G system natin sa satellite. So tawag natin dyan is mga non-terrestrial network. Okay? So ang 5G natin could be a terrestrial and non-terrestrial network. Okay? Ano pa? Ito kanina banggit ni Nicholas, no, sa FireCell. The 5G can be deployed as a public network. Katulad ng mga ginagamit natin ngayon, mga cell sites, no? If can be accessed by public, it's a public network. Kapag meron kang SIM card ng mga operators ngayon, nakaka-connect ka kahit saan, it's a public network. Okay? But if you deploy it inside an establishment, inside a factory that the company itself only lang, no, ang nakaka-access, and then it's not open for public, we call it the non-public network, okay? Or the private network. Tawag natin is NPN. Okay? NPN. Mas pinadali na ngayon sa 5G, no? Ano bang tawag sa NPN? Sa hindi private. Di non-public, no? Network. NPN, no? Mas pinadali na siya. Okay? So si NPN, si non-public network, pwede tayo mag-deploy ng maraming types. So pwede tayong standalone, katulad nung kapag bumili ka kay FireCell ng kit, so meron kang standalone. So meron kang core network, meron kang radio, and then kung sa iyo yung frequency, you can deploy a standalone private network. You can also be hosted by MNO. Okay? You can be hosted by MNO. So you will have a certain slice. And you can also do a RAN sharing. Okay? RAN share kayo nung isang operator, but you are only sharing frequencies if you're going for MOC-N or more RAN. And you can also have this network slicing. Yan. Okay. Ito palang hosted by MNO. Ayan. Si MNO may sagot lahat ng equipment. Pero ito, network slice. Para kami sarili kang APN. Ang tawag naman natin is DDN. No? Yan. And then meron ka pang slice ng network. Yan. So pwede ka mag-deploy yan. So 4 ang option mo for network slicing. Okay? Ayan. 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 So ito yung mga needs natin, no, na kailangan nating matutunan sa 5G. And then later on, pagdating ng Open RAN, so what will happen sa Open RAN, kapag ginawa nating open ang ating system, okay, what will happen sa Open RAN, katulad ng ginawa natin, no? So from traditional network, ito yung ating traditional RAN, we will disaggregate yung mga hardware and then software, and then we will open it, yung mga interfaces natin para mas maraming operators at vendors na makasali. And then we will activate them with RAN intelligent controller. Babalik na naman yung controller natin, but this time the RAN intelligent controller is powered by artificial intelligence / machine learning. Okay? So yung mga optimization natin, yung mga decisions ng resource management will be handled by artificial intelligence. Okay? So when we go sa Open RAN, okay, when we go sa Open RAN, ang mangyayari dyan is like this na, no? So ang mangyayari sa atin, yung Open RAN natin will have an open and interoperable radio access network solutions, no? Gagamit na tayo ng mga general purpose processors para sa ating mga radio, remote radio unit, okay? At mga COT server, mga open hardware natin para sa mga BBU at sa centralized unit at distributed unit, and yung mga interface natin are open. Okay? So from here, the interfaces are open, okay? And then it will be powered by artificial intelligence and machine learning through the radio RAN intelligent controller. So ganito yung magiging architecture, no, ni Open RAN. pagdating natin sa Open RAN system. Yan. Yan. So meron tayong remote radio unit, okay? Remote radio unit, andito yung 4G or 5G network, yung ating DU, yung centralized distributed unit, meron tayong centralized unit, nandito si RAN intelligent controller. Kinokontrol niya yan. Okay? And then connected na tayo sa 5G core network. Okay? So ganyan yung magiging ating journey from starting from 2G, 3G, 4G, 5G, and then we'll open up the radio access network going to Open RAN. So tanong kung meron bang Open RAN sir sa 2G, 3G? So merong vendor na nagsusupport niyan like si Parallel Wireless. So they're offering all G RAN, no? Open RAN. But most of the vendors na nakita namin is focusing on 4G and LTE. And sabi ko nga sa 5G naman, sa European operators, they are prioritizing yung NSA at non-NSA para sa Open RAN system. Okay? Yeah, so that concludes our discussion for today's RAN and 5G, no? And how we will go to the journey ng Open RAN. So I hope marami kayong natutunan ngayong araw sa ating discussion. And meron tayong mga Q&A, no? Pero bago tayo mag-Q&A, no, meron tayong post-test. Tandaan niyo yung post-test natin, di ba? So punta tayo sa post-test natin. Tingnan natin kung sino yung magcha-champion ngayon. Kanina, di ba, may no? May nag-champion tatlo. Nag-ano yung tatlo, no? So ngayon, let's see, no, kung sila pa rin yung mamamayanin, no? How can we know what frequency are we using? Kapag sa phone, merong mga application sa phone na pwede nga mag-download, and then you can see the ARFCN, no? Hindi siya frequency itself, eh. Converted na siya into channels. Yan. So yeah, you can check you can download an app, no, para makuha mo yung ARFCN or NR ARFCN. So makikita mo agad. Kung wala naman, you can use a spectrum analyzer to check or yung mga scanners. Yan, meron tayong mga tools na ganyan. Okay? Ayan na yung ating feedback form, okay? For 5G NPN, does it require SIM? I think I believe meron SIM yan, and then yung iba is eSIM ang ginagamit. Okay, para makakonect ka sa network. Typical network pa rin kasi, no? Virtualize na din po ba ang SIM? It depends sa application. It depends sa mga user, sa mga UE mo kung isusupport niya gano'n, no? Kasi pwede ka namang mag-non-public network pero typical na phone pa rin yung gamit mo. Kakaroon ka lang ng ibang network slicing. Didefine mo yung network slice mo. How to join on the Asia Open RAN Academy? Yeah, sali lang kayo dito, and then if you would like your universities to be one of the academic partners, you can just send an email to Asia Open RAN Academy or send kayo ng message dun sa aming Facebook group, and then we'll send you the details na kung paano niyo siya, no? Kung paano yung mga steps na para maging partner kayo ni Asia Open RAN Academy. Okay. Sir, yung sa ine-implement po ngayon ng mga coloc cell sites, yung different operators po ba share sila sa RAN, BBU-RRU antenna, or magkakaiba rin po? Kung sa Pilipinas, hindi pa tayo ganong widely implemented sa RAN sharing, eh. Ngayon nasa ano pa lang tayo, nasa tower sharing pa lang tayo. So tower sharing meaning nag-share lang tayo ng tower, hindi pa ng antenna at ng radio access network. Yung tower lang. Pero magkakaiba pa rin tayo ng system. 5G O-RAN for 5G private networks only? Hindi po. Ang 5G O-RAN could be public, can be open to public, and can be applied for private network. Yan. But you can deploy public or private. In maritime industry, autonomous ships are emerging. Is there a possibility that 5G will be applicable in these industries? Yes, meron po tayong smart port or port 4.0. Yan. So, meron tayong ganyan. So, hindi lang yung mga ships ang magiging autonomous, pati yung mga cranes at yung mga ano doon, yung mga equipment na nasa loob ng port. Yan, yung mga IoT devices doon. Is it possible now to carrier aggregate for NR? Not sure sa mga features ng existing vendors, pero nasa roadmap yan na kaya niya mag-aggregate ng NR. But I'm not sure kung ino-offer na ng mga existing vendors sa feature nila. Pero kasama yan sa 3GPP na NR aggregation. Will 5G replace people, especially if AI will be implemented? Like now, we have SON that eases analysis on network and doing changes also on network. I think hindi. Mangyayari dito is dadami yung ating trabaho lalo. Dadami wala yung trabaho natin because if there is an AI that's handling this task, we can focus on other tasks and then we can create more tasks. To have more expansion sa network. So I think hindi yan. Kasi yung SON dati, kinatakutan din dati pero hindi naman nawala ng trabaho yung ibang mga RF engineers. So what I suggest is you must have advanced insight kung ano yung mga mangyayari sa mga future technologies. And then you start studying it para at least continuously nag-upgrade yung skill set mo. Okay, para hindi ka matatabunan mawawala doon sa circulation ng mga skill set na kailangan sa industry. Can you combine O-RAN and C-RAN? Actually, the key would be the openness. Kung si C-RAN is actually si open comes from the C-RAN. So if the equipment there are using open hardware and then software-defined network and then yung interfaces are open and then the setup is something like C-RAN, we can do it.